So we're going to review assignment 1. Question 1, I asked you to simply give a definition of, in the definition of descriptive epidemiology, what do person, place, and time refer to? Now you can go ahead and read the examples that I've given, but the real important thing to note about this question is that you really want to grasp that descriptive epidemiology is describing the who, what, when, and where of a particular disease state in a population. We're talking specifically about describing a group of people, where they live, and when in the time period people were getting sick, what we're talking about. So remember that we can have person characteristics that can be inherent to the person, so their age or their gender or their race. But we can also have things that are acquired, so marital status. They can be married or not married, and that can change based on, obviously, personal situations. Immunity status. So immunity status is something people may not be immune, then they either get vaccinated or they've had the disease before and become immune to it. Or things like beliefs and traditions. But things that aren't necessarily intrinsically inherent to the person, but are something that they acquired and are part of a description of the person as a whole. When we're talking about place characteristics, this can include things like residence, so where you live currently, geographic location. It can also include things like birthplace or workplace. So for example, if we were talking about the incidence of lung disease in asbestos textile workers. So the fact that someone's occupation is textile workers would be a person characteristic, but the actual textile factory, the fact that it's an asbestos textile factory, that would be a place characteristic that could influence the development of disease. And then time refers to whether the frequency of the public health problem. So this could be, does it happen every year? Does it happen on a weekly basis? So it could be a time component if we're looking at we're looking at trends over time, or it could be something to see if we're looking for cyclical patterns of disease occurrence. Excuse me, but when we're talking in question 2, I've asked you to explain how descriptive epidemiology can help assess and monitor the health of communities. So descriptive epi helps us describe our populations, obviously, and when we're describing our populations, we may do this in a narrative description, or we may do this as numerical summary measures. So this could be tables or graphs or maps, or it could be something like an odds ratio or a rate ratio or an incidence rate. Numerical summaries. We can then use our descriptions of populations, the person, place, and time of a disease pattern. We can use that descriptive epidemiology to then identify important health problems or identify places. So an example, if a disease is more common in older adults, once we know that, then we know we can focus our limited healthcare resources on helping to prevent the disease in the older adults or helping to make a difference in the healthcare system where it's most important, where it will make our impact. Now, question 3 asked you to match each of these measures of disease frequency, so these are summary measures of disease frequency, with the appropriate example. So number 1 is a count, which is the simple count of cases of disease. So for example, in this example, 30 cases of asthma. Number 2, we're talking about cumulative incidence. Now remember, cumulative incidence is the measure of incidence that we calculate when we are talking about a fixed cohort or a static cohort, where we know the absolute total number of people that were involved in the cohort for a particular study period. So for an example of cumulative incidence would be 30 new cases of asthma amongst the 500 employees, when we know that there were only 500 employees during that time that we're interested in. Incidence rate, on the other hand, is dealing with person time. We're dealing with the amount of time that people are contributing to a certain study period. So we're talking about dynamic cohorts when we're looking at incidence rate. So incidence rate in this example is 30 new cases of asthma per 500 person years. 4, I've asked you about period prevalence. Period prevalence, now remember, incident cases are new cases of disease. Prevalence is talking about existing cases of disease, and we can calculate prevalence as a period of time So like it is in this example, it's number C. So we have 1,000 existing cases of asthma. Remember, they're not new cases, they're existing, over the 500,000 people that lived in Missouri in 1998. So 1998 in this instance is just a period of time that we're looking at. We count everybody that was there in 1998. And so people aren't contributing person time, it's just there were this many people in 1998, and we know that there's 1,000 existing cases during that period. Now this can be somewhat contrasted with point prevalence, which is just the number of existing cases out of the total number of people at one point in time. Number 5 and 6, we have case fatality rate and mortality rate. Now the case fatality rate is the number of deaths due to a particular disease out of the number of people that have that disease, the number of cases of disease. So 5, the case fatality rate is B, 30 asthma deaths over 300 cases of asthma. So it's the number of people that died out of everyone who was sick. Mortality rate, on the other hand, is the number of people who have died due to a particular illness out of everyone in the population. So we have 30 asthma deaths per 500,000 people in the population in 1998, the year of 1998. Now, question 4 asks you to calculate the incidence rate for prostate cancer and female breast cancer, and then to show your work in per 100,000 people per year. Because we know in the year 2013, there were 20,734 new cases of prostate cancer among the almost 14 million males in that year, over 1 year period of time. So we have 20,000 divided by the 13,963,753 people in that year. And then we multiply that by 100,000 people. And that way we're able to get 148.5 thousand per 100,000. In this case, it's really per year when we're talking about incidence rates. We do the same thing when we're talking about female breast cancer rates. Now in question 5, I gave you a table. And I have stratified this table based on age. So we have the diabetes mortality rate for white males and the diabetes mortality rate for black males, and each of those are stratified by age. So I've given you the count of people that died from diabetes, the population of people with diabetes, and then I asked you to calculate the rate per 100,000. So those rates are calculated exactly as we did in the rate in question 4. So for age 20, for white males, it would be 164 divided by the 641,291 white males that had diabetes, and then multiply that by 100,000, and so we get a rate per 100,000 of 0.1. And then you can do these for each of the strata that I've talked about. And then at the total, that is the total count for all the white males and the total count for all the black males, the total population for white males and total population of diabetics for black males. This becomes important when I look at question 6, where I've asked you to calculate the crude rate ratio. Now remember, the rate ratio is the ratio of 2 rates, and in this instance, the 2 crude rates. So if we go back up, we know we can calculate the crude rate for white males, which is 24.5, and the crude mortality rate for black males, which is 30.1. Now I've asked you to calculate the crude mortality rate ratio for black males compared with white males. Now remember, this is a ratio, so in this case it will be a ratio of black males to white males. So black males will be our numerator and white males will be our denominator. So we take the crude mortality rate ratio is literally the ratio of the 2 crude mortality rates. So we have the crude mortality rate in blacks, which is 30.1, and the crude mortality rate in whites, 24.5. We take the ratio of those two and we get a mortality rate ratio of 1.23. Now this is really telling us that the mortality rate for diabetes in black males is 1.23 times greater than that for white males. Or, alternatively, we can say that the mortality rate in black males is 23% greater than the mortality rate in white males from diabetes. If I had asked you to make the comparison for white males compared to black males, you would switch the numerator and the denominator, because then we would be comparing white to black. And in doing so, we would have the numerator would be 24.5 divided by 30.1, the crude rate ratio of black males, and that would be 0.81. So that would simply mean that white men with diabetes are 0.81 times the mortality rate for diabetes in diabetes mellitus in white males is 0.81 times that of black males. Or alternatively, I think this one is much easier to understand in the terms of percent. So the rate in white males is 19% lower than the rate in black males. Now, where do we get that 19%? 1 minus 0.81 is 0.19, so 19%. Now, please let me know if you have any questions related to this assignment. I would be more than happy to answer them for you.